In this video, I'm going to show you how to use these numbers to figure out the velocity before and after I pull that in. Okay. In general, the velocity is going to be pi times the radius divided by the half period. In other words, when I say half period, I mean the period of a half revolution for it to go from one side of me to the other, which is, of course, what we have in the table there. Okay. If you notice, this just boils down to 2 pi r over t. Okay. So if I look in here, I can see that the difference between these two numbers is t1. So t1 is literally 0.5 minus 0, or 0.50 seconds. Okay, r1 is going to be the average of these two values there. I'm going to make them the absolute value of that. Okay, so r1 is equal to this plus this. Okay, so 1.107 plus 1.188 divided by 2, and I get 1.14.1475. Okay, and then the uncertainty of that is going to be, by the way, the uncertainty of this of both times are plus or minus 1/30 of a second, right? So 1 divided by 30 is 0.033, we'll say. Okay, so we're making like a little data table here. Okay, now the uncertainty of this is the difference between the absolute values of those numbers there. So I'm going to go 1.188 minus 1.107 is 0.081 divided by 2 is 0.0405. Whoops. Okay, so this is my period, my first period of the first half revolution before I pulled it in, right? That's the radius, that's the uncertainty of it, right? Now to figure out T2, I'm going to subtract those. So T2 is, well, we can do that in our head. That's 0.130 seconds. I'm just checking because I just don't want to make a mistake here, right? And that's also plus or minus 0.033. So that's notice that that's a bigger proportion of this than that is of this, right? Okay. Now to figure out the radius r2, I'm going to average the absolute values of those. Okay, so parentheses 0.589 plus 0.458 divided by 2, so 0.5235. And then plus or minus the difference between the, so we're going high minus low, divided by 2. That's my plus or minus. Okay, so the high is this, the low is that, right? Now I'm talking about the absolute value, not negative 0.458, but 0.589. 589 minus 0.458 divided by 2, 0.0655. All right, so from this, now we're all set. Now we can just use this and figure out the velocity and then the uncertainty of the velocity, okay? Let's carefully divide our space here, okay? So let's figure out the V1, right? V1 is going to be pi R1 over half T1. And these, by the way, are the half periods. Okay, that's what those things are. They're not the period, but the half period. Okay, so we can just plug this thing in. This is going to be pi times 1.1475. Okay, divided by 0.50. So let's do that. Okay, pi times 1.1475 divided by 0.5. That's a whopping 7.2099. 7.2099 meters per second. Okay. Now my uncertainty of that, to find the uncertainty of that, I'm just going to go uncertainty of V is to V. And then it's going to be the uncertainty of T to T plus the uncertainty of R is to R. Okay. periods, right? Or the half periods, or it doesn't really matter, okay? So I'm going to say the uncertainty of my velocity is to 7.2099, right? That equals, and then my uncertainty of time is 0.033 divided by 0.50, okay? And then plus 0.0405 divided by 1.1475. All right, so again, remember the way you do this is you figure out this stuff in the parentheses, multiply it by that. So I'm going to go times and then left parenthesis, 0.033 divided by 0.5 plus 0.0405 divided by 1.1475. And this is plus or minus, it ends up being delta V, ends up being 0.730 meters per second. Okay, so my velocity before my V1 is equal to 7.21 plus or minus 0.73 meters per second. Okay, so let's figure out V2. This is pretty exciting. V2 is going to be pi times R2, which is this guy, 0.5235 divided by the period, 0.13. Let's figure that out. So pi, oops, what am I doing? Okay, pi times 0.5235 divided by 0.13. Let's say this will be faster, 12.65. Okay, now it's definitely more than that, but the question is how big is our uncertainty, right? Okay, so we're going to do the same thing here. We're going to go the uncertainty of the velocity is to 12.65. That equals 0.033 over, and then our time is only 0.133, or 13, sorry. Okay, plus, let's see, and then our uncertainty there is 0.0655. This uncertainty is on track to be much bigger than this uncertainty, right? Okay, so 0.5235. All right, so again, what we're going to do, remember, we're going to take this and multiply it by that stuff in the parentheses. So I'm going to go, literally on my calculator, I just go times left parenthesis, 0.033 divided by 0.13 plus 0.0655 divided by 0.5235. And that's 4.79. So I'll say 4.8. Okay, or 4.79. That's my delta V. So this is, this velocity is 12.65 plus or minus 4.79. Now I know that that's a little bit enthusiastic to have a 3-digit uncertainty. Probably we'd have to say 12.7 plus or minus 4.8. Okay, but there it is, right? Now here's a question, right? In your lab, as you do this lab, right, you have to figure out does this overlap with this? Okay, and if I had to guess, I'd say that it's very close, but I don't think it overlaps. Okay, so let me show you why. Okay, so the 7.21 is there plus my uncertainty. The highest that this could be is 7.94, right? Is the max. Now, how did I get that? I just added that to that, and I got this, right? Okay, the lowest that this could be is, I'm just going to subtract it, right? That guy minus this guy. 7.85, okay? Oh, they do overlap. Okay, so these guys overlap. We haven't actually, the way I did it, right, with my uncertainty, I haven't actually disproven that's the min of this guy, the max of this guy. So they overlap by a little bit, right? Okay, so that's the argument you have to that's the argument you have to make, is look at how this one's probably going to be lower, right? But how high could that be, and how low could this be? If they overlap, then we haven't disproven, right? And you need to say that. You need to make an argument like this, right? And if they don't overlap, right? I mean, you might get a smaller uncertainty because maybe you're better. Maybe you use a different video, right? Okay. This is definitely higher, but it doesn't disprove the constant velocity model. At least my data doesn't. Yours might be different, so that's what you have to judge, right? Okay, I'm done talking, I think.